All right. We are live. How's it going, Chris?
Hey, Dan. We're back.
We are back. It's been 2 days.
Yeah, I was gonna say we're gonna do less hardware on this stream, but I actually don't think that's true because I'm here.
Yeah, absolutely. I hope not. The hardware streams are preferred for me because I usually end up gaining a little more from them. Uh but I don't know. I feel like the audience likes it as well. So, I'm a fan. Although
Yes.
we can do a little bit of everything on
Yeah.
with Sloshy McWashy.
As a reminder, this is the IoT build up IoT product stream, but we might be using the thing we talked about on the hardware stream, right?
Right. Cool. Well, let's start off with anything we launched this week, per usual. And there wasn't anything new, but we did have a couple blog posts. And so this one was just a recap of a talk. This one was kind of an iteration on a blog post from Chris that was posted. It's been a little bit now, actually. This ESP32C3 geofence, which is really cool post and has the video to go along with it, where you're kind of implementing a geofence device on an ESP32C3, which doesn't have any GNSS support or anything like that. So you're getting location from here.com based on scanning the Wi-Fi networks around you. But you had to use this N8N service to kind of like wire it all together, right?
That's right. Yeah, that's like a what do they call it? Like an API. It's not like an API service. It's like an API
It's like it's like a workflow engine sort of,
workflow.
or
That's good. That's
something
good. I
like
like
that.
that. Yeah.
Yeah.
Yeah. Basically, it's like a place you can go and put in all your APIs and kind of hook everything together.
Yeah. So anyway, that was a very inspiring demo for us internally because the kind of like glue bits of that are things that we want to be able to kind of like clean up and add to our pipelines product so that you don't have to stitch together so many different things. And there's obviously like limits to that. One of the things we could say here is, well, you still have to use here.com. Well, actually, I should jump over to the other post. In the post this week, you might not need GNSS. It talks a little bit about GNSS, assisted GNSS, and then kind of more of that model that you were doing of taking nearby network information and then submitting it to an API to basically get location data. And we
We should
are
also
still, yeah, go
we should
ahead.
also call it your previous post as well about just using cell tower, right? So that's like a much bigger kind of circle area. And then now GNSS, or sorry, cell tower plus Wi-Fi was the last N8N post, and now it's also doing the same thing here now, but more baked in.
Yeah, absolutely. And so like if you still have to have a location service present here. So one of the cool things I liked about this is we show it with two different location services where the firmware is still sending the exact same data and the consuming system, which is just like DB stream in this case, but it could be anywhere you're sending this data,
Right.
gets
Yep.
the same data out of it, but we replace the location service in the middle. And it's fully handled by pipelines. So you can kind of see here, which is what you used in your post, that we're using this webhook transformer that we launched last week, and then Google geolocation API, where we're basically saying, hey, we want this to look exactly like it looked for here. And so we're going to do some patching kind of on either side of like submitting to the API and then kind of like munging the response that it gives back. Munging is that a
Yeah, I've heard it before. It's just I don't hear it often. You know what I mean?
I feel like it might be a southern colloquialism perhaps. But anyway, you end up kind of what we show here at the end, which this is a little small of me. Well, I'm not sure that helped. What you end up with at the end is data that looks the exact same. So you're sending the same data in and getting the same data out, but you're able to have flexibility to move between services. And we were able to kind of like cut N8N out of this
Yep.
flow here.
Yep. Yeah, you still could use it for other things, but it's not required to have that as well. And it's just more direct, fewer steps, fewer things to troubleshoot, that sort of thing.
Yeah, absolutely. Um, so yeah, those kind of piecing some things together rather than launching a new feature. But we have a bunch of kind of different solutions like this that I think we'll continue to have posts on that allow you to leverage what we're building or what we have built in different interesting ways. And the nice thing, especially about this webhook transformer, is any API that's available on the internet now you can kind of incorporate, which allows you to bring a lot of different functionality. Into kind of like a connected device product. We're
Yeah.
kind of now talking about more than just the device.
Yep. Yep. Yeah, I
So yeah,
wonder on Sloshy McWashy specifically too. So if we're gonna have Wi-Fi, we could, in theory, put this kind of thing onto Sloshy McWashy, right? Because we're gonna have Wi-Fi access point scanning. We could just say, "Hey, what's near me?" I know. Yeah, and then you could probably even do like a nearby search of like, "You're probably at this laundromat," or "You're probably at an apartment," or something like that, right?
yeah, yeah, absolutely. And I think we also talked about like if you leave it behind on accident or something
Oh
like
yeah,
that.
right, right.
So that would be
Like
neat as
last
well.
known. Yeah, yeah,
Yeah. Yeah.
cool.
So we're secretly always just enabling Sloshy McWashy features with what we've built. So
I mean, it's tough sometimes, right? Like, I mean, like even the webhook transformer, I didn't quite understand it, but then looking at that post really like hammers it home. It's like, so we have a webhook destination, which is like what we use for the N8N or other things like it, where have a piece of data, you're trying to send it somewhere else, and your webhook is what actually enables that kind of the exporting. But then the webhook transformation is really utilizing someone else's service and waiting for a response, right? That's the transform piece.
absolutely, absolutely. And the thing that we didn't really show it much here, but one of the in my mind, best parts about the webhook transformer is being able to leverage potentially multiple APIs. So, like, if you need to do some sort of, more robust data transformation, you could send it to one webhook transformer and then send, the result of that over to one that's expecting that payload.
Yeah.
So, lots of different ways you can piece things together.
Right. Totally. Totally. Great. Well, good post. I liked it.
Thanks.
What about where did we leave off on? I was not on the stream last week, so maybe you can give me a recap, and as an extension, give everybody else watching a recap too.
Yeah, absolutely. I am going to pull up the notes here to help me remember as well. So I'll go ahead and present. Um, Mostly, it was a lot of me and Sam just kind of hanging out at the end of a long week, if I'm being honest. But
Mm.
we talked a little bit. Well, I guess we actually got some actual stuff written, so that was good. We talked a bit about Sam's process for going through and kind of like uh, not doing board bring up, but like kind of like post board bring up, I guess. We're obviously not bringing up a board right now, but we will be in the future. We're more working with a dev board, which I have over there, which I can grab in a minute. But kind of like basically talked about his process for that, and talked about, validating that things are wired up correctly and that sort of thing. Really, what that looked like for us here was just like getting a basic firmware or basic talking to Golioth was really kind of the starting point. So we did add some firmware here in the repository, and this has been pushed, so folks are welcome to go look at it. But basically, it's just our Hello World sample for Golioth, and it is for the ESP32C3 DevKit M, which is the one I have on hand. We obviously didn't do anything with the accelerometer or anything like that, because we don't have one right now, which we need to order that. So
Yeah.
that's kind of where
Yeah.
we left off.
Okay. Great. Great.
Yeah.
2 times ago, when I was here, you and I basically spent the entire time saying ESP32C3 or ESP32S3 and back and forth and back and forth and back and forth. And
Right. That was a particularly enjoyable stream for folks, I think, which I will point out that I still was just totally wrong about our previous decision on that one, which I was harping on for like half that conversation. So yes, that was
what was the previous? What was the previous one you meant?
I think we had decided on the C3 or something, and I said we had decided on the S3. Anyway, I was incorrect. But we got to a good place at the end where we were certain we were on the C3 at that point.
Right. Well, I was about to, pull the alarm and say, wait a second, we actually can't do this because of some things that I've been finding in the stuff I've been doing off stream, but also on stream, whatever. And if I may be so bold, I would say that some of the work I've been doing on the hardware stream actually means that none of this matters.
Nice.
So like the entire last conversation, like I've been going through all this stuff in my head and just thinking like, oh man, well, we really need this and that, whatever. And then one of the things we've been talking about in the other stream is kind of the module level abstraction layer, which is like, I think I'm going to be writing an upcoming post about like something like modularity is a sickness, or modularity is a disease and I have it, or something like that. Because it really is, right? I mean, you could really take this all the way back to like we're putting modules on modules on modules, right? So that sort of thing. But at this point, because we're using a module that is abstracting kind of functionality and pinouts, it actually means that all of the arguments we had, not arguments, but all the discussion we had 2 sessions ago doesn't really matter. As long as you like assign pins correctly, as long as you assign pins correctly to the module and like you don't try and put an analog signal onto something that can't measure analog, you're actually fine, which is great. That's like pretty much validation of what we've been trying to do. And instead of talking more, let me just explain what I mean. So here is my here's my 3D model of the 4 DRAM boards. This is what we've been doing on the hardware stream. Today I actually put in some 3D models, some like chipset models, so it's not just footprints. And these are still works in progress, and there's no layout done with them yet because I've been trying to save that for the upcoming next Wednesday stream. But the thing that really I've been trying to figure out is like, first off, can this form factor work? It seems like yes, probably, and it seems like generally this is going to be okay, and we won't have to like blow it all up later. But in doing so now, each of these, one of the things we did on Wednesday, 2 days ago, is Dan and I went through and like talked about all these pins on the edge of these castellated edges here. And so like, for example, we've been talking about I2C on this project. Those are going to be assigned, I think, in these upper pins up here, like on the upper left side of this board. As long as the I2C bus of whatever sensor we drop on here is connected to the I2C pins of the module, the rest is kind of up to me and then up to the firmware team, or firmware person, more generally in this same kind of context, to just make that connection work. And we're going to have board files for each of these modules as well, where like kind of the idea, but not like the mandate, is just that like something like Zephyr, the real-time operating system ecosystem we've chosen and are using, we're going to have a board file for the DRAM1 and just say like, all right, it's using I2C, like just start hooking up to I2C and away you go. And if then we switch to DRAM4 or DRAM3 or whatever, which actually have different chipsets as the controllers on them, in theory, it shouldn't matter. Now, in practice, that's never actually the case. But this is what I'm really getting towards, is DRAM3 is the ESP32C3 and DRAM4 is the S3. I had like just copied over and started making another one. Mm-hmm. The answer is it shouldn't matter. Especially, so like it'll be a different target. It'll be a different target build. But because the module's there, we should be A-okay. And that's really kind of the point I've been trying to make the whole time, is that if we do have this form factor in a module, then we can start to abstract some of the other stuff away from it, which is great. I don't know if I made that point or not.
Yeah, no, I think that makes a lot of sense.
Have I beaten that dead horse enough?
Yeah. No, I think that's a good point. I was curious, how often are like products going out in high volume, like taking on a module kind of like form factor, right? Because like at some point you could,
yes,
optimize in some ways by making it a single component there.
Totally. Yeah, there's going to be added cost, added complexity, added yada yada yada, right? I think in low volume it's very common, especially if it's like I mean, this is literally a module on a module, right? So in theory, so this year's a BG77 that's got Qualcomm silicon on a QuickTel, canned module. That's the BG77, which then is going onto the DRAM 2 or 3 or 4. In theory, if you were a high enough volume, you could go to Qualcomm, like really, really high volume, and you could say, hey, just give me the silicon. I'm going to do all my own certification. I'm going to do all my own testing. I'm going to do everything because I just need it so small and so tight. Very, very few people do that, including me. I've never, ever done that, nor do I think it's ever worth it. But if you're at high enough volume, it probably would be worth it. In the same way, now, like, you're kind of moving to a couple of tiers down from there, and it's like, okay, so now should you use a module, maybe not even a module like this, like let's say like a module from someone like an Isurio, which is formerly Laird, right? They have certified pre-qualified modules that often package this stuff together as well, right? So this is basically like they've taken it through FCC testing. They often have metal cans on top of it. They have all this stuff there, and like that might be a module you buy from Isurio, and then you put that in your design. That is another case, and that's, I kind of just think about these in like general ranges. Like I would probably use an Isurio module like that. Oftentimes they have things like so I think they have like an NRF 5340 on one of them, and maybe a 9160 underneath the can. That might be wrong, but like things like that where they have these kind of multi-mode type of things under there, and that's probably good. I don't know, 10,000 products in the field, 100,000 if you have the margin for it. But then at like the 100,000 mark, you're going to be like, all right, well, I can move down a layer and do it myself, because it's just the volume makes sense. You're trying to get your cost down, and at some point, someone's going to be like, what about this module? Can we make this cheaper?
Yeah.
And so like that, there's always that, like at some point that always becomes the conversation, because it's like, because then the amortization costs of like doing the certification and all the testing and honestly, even just the manufacturing, it just gets way easier to do that sort of thing. And those are almost like, those are manufacturing activities.
Makes sense. Well, cool.
Yeah. In this case, I think this, so the DRAM module would go onto something like the Elixir board, which again, that's like basically a prototyping platform, and going from like 1 to 10 is kind of the prototyping platform level. I think something like this could go up to 10,000 pretty easy, right? I mean, like, so like low volume, like, and you might make it yourself, or Golioth ever I don't think Goliath's ever going to sell it, but someone like a Golioth ever selling this sort of thing, yeah, 10,000, it makes a ton of sense. But at some point you're going to be like, oh, you know what, I'm going to take these things off of here and put it on my own board.
Yeah, makes sense.
I think the key thing there though too is if you're using so say you're working at ABC Corp and you build your own version of the DRAM, or DRAM's going to be open source, right? You just go and copy it and build it yourself. One of the key factors is kind of not necessarily the openness of it, but like just kind of knowing all the tricks of what's under the can, right? So there's other kind of verticalized platforms you can go and buy modules from, which are great, and they work awesome. But then when you decide, like, you get to a certain volume and you're ready to like, oh, okay, well now I should split this out and put on my own product. It's like, that's a redesign at that point. It's not like let's just get rid of the middle board. It's like literally like, okay, we have to like either reverse engineer this or kind of start to a new level. And that's one of the problems there. So Golioth previously didn't have that super low volume sort of thing, and still doesn't, other than there being open source designs. But now you could go and build something like the Elixir yourself, or go build the DRAM in the future yourself if you want to. And then, but then you'll have all those files and all that information ready to go and put it on your design, because at that point you're ready to go. So
awesome. Well, that sounds great. So I know you mentioned on the Wednesday stream you're going to be routing some of these things, right?
Yes, that's right. Yep.
Yeah.
Specifically the DRAM 1. Yes.
Yeah. So since we have kind of like this nice interface, right, where from the like carrier board, all we need to worry about is kind of like the interface, right? Like what pins are there.
Yeah.
Maybe if you want to, I think we could potentially get into designing the Sloshy McWashy one today.
Yeah, I think so. Yeah, and so now it's like, okay, so you have the DRAM as a module. It's going to be like, that's the kind of the core piece of your design. And now something like Sloshy McWashy, it's going to have the sensor, it's going to have a battery, right? It's going to have a battery, maybe USB, maybe definitely a programming header, some buttons, LEDs, like kind of like all the stuff that you would surround that core with. And wouldn't you know it, Dan, I started doing that same kind of thing here. I actually started. So this is where kind of the whole conversation started, which is with the micro DRAM, I wanted to try and fit it underneath just a micro bus click header. And that's really where this one's going. And so if you see, oh boy, you see this one's on the back side here. So showcasing that you might want to do that sort of thing and have the DRAM on the back of this module, and then you have something like a click on the top of this sort of thing. And this would be something like you would be if you were prototyping, right? You were prototyping with just a click header, like we've talked about. You wanted to, buy a clickboard rather with the the accelerometer that we're talking about using. You buy the clickboard, you plug it in, you hook up all your pins, and you're ready to go. That's like a true prototyping platform. But then the idea that I put here is like, okay, so now we wanted to put that, we've talked about a puck kind of form factor. And I was like, okay, what does that look like? If we have like this one, oh boy, sorry. So like putting like even like a CR24 or 50 on the back of this, which I don't think has enough peak power for cellular. And so I think that would be potentially problematic, but I just wanted to kind of do some experiments around like, well, what does it actually look like? And these are, these parts aren't placed. This isn't actually done. This is just like kind of floor planning at this point. So if you wanted to have something that looks like this, what is the smallest form factor we could get to? And this is a 42 millimeter diameter circle board, and called it the circle DRAM. So
nice.
And then the DRAM for the Golioth, that one's just a silly one. That's really more promotional and really not done yet. I'm just gonna let that one to the side. So
cool. Well, I feel like the puck form factor that you have there is like pretty spot on for what we're thinking about here. So maybe we could just start going with that one for now.
Yeah, I think so.
Cool.
So what do you want to do? You want to put some parts on here?
Yeah.
I guess maybe we could look at the schematic first to see what that looks like.
Yeah.
Yeah, that's Slack. Where is my boards? Okay, so I've been also trying to get 3D models kind of figured out for all this stuff too. And so if I go over here, you see there's a whole bunch of stuff not hooked up yet. And like there's stuff hanging off the board. Like this is really not done yet. This is all just a kind of an exercise in like, will it work? Not like, is it working currently?
Right.
So on the back side, so if we just look at the backs, so this is the top side. This is the DRAM module, programming header, power switch. I put a notch in here because, if you think about just like how you're going to fit this into a design, like a case, even if we're designing it ourselves, having a notch is nice so that it's not like spinning in there. So you had like catches on the corners, or like not the corners, but like you had catches. You could have screw holes, but then that kind of takes you a little bit bigger as well. And then, then you get Mike to program all the firmware, right?
I'm just taking some notes on a couple of things you said there.
Hey, Mike. Well, Dan's taking notes. Mike, I was just walking Dan through the board that I am trying out here.
Circle DRAM. Nice.
Circle DRAM, yeah. I couldn't think of a more clever name.
Sloshy McWashy.
Yeah, right.
Cool.
Some of the limitations of the DRAM generally is like, I'm kind of kicking the can down the road in terms of like, so these are all UFL connectors in the corners, which means that you have to have an external antenna, right? And even this bottom right one, this is completely not utilized right now. That one is that's just a spare, just to like kind of be a placeholder in the corner. 2.4 gigahertz. This one's GPS. This one's LTE. And like, you could selectively populate, so you don't have to do certain things here either. But yeah, there are currently no LEDs on here. We've got the DRAM module, the programming header, switch, USB. On the back side, we've got a bunch of supporting components. I don't know if this is a mode button. I don't remember which one I have here. This is USB to serial, and then just like extra capacitors and resistors just to put it inside the envelope of the board. Really, we'd have to kind of put everything underneath. Even this should probably rotate. Yeah, these should definitely rotate. So like some of this stuff needs to be changed around.
What battery connector is that?
That's for a 2450, and I'm really not certain if that would power a cell modem because of peak. I had trouble finding peak currents, So like we had talked about the CR123 previously, and that can do up to an amp peak. But the 2450, it has 1 amp hour of current, and I always kind of just naturally assign a 1S kind of discharge rate. Oh, look at this. Our resident Nordic FAE here. Hey, Helmut. Helmut also is the one who gave us the some of the library for the N9151 as well. So thank you, Helmut. So 91 series is 230 milliamps peak, which is great. So that might actually enable that. I don't know if Helmut knows about using something like a 2450 on the board, but we could have some capacitance there as well. But that would be kind of a test thing we'd have to try as well. Yeah, and so 2450 is the same. It's like a thicker coin cell. It's 24 millimeters diameter. That's the one that's on the Isorio. What was the one we took for the thread demo? Do you remember that
one? Weren't they? Now the name is
50 something. It was a 500 series, BT 500, I think.
BT 500. Yeah.
Yeah, that sounds right.
Did that company change names? Is that why it's a name I don't recognize?
Yeah, it used to be Layered Connectivity, and now it's Isorio.
Okay, got it. Yeah. That's probably why. So I have a box of those batteries in the basement. I can't remember what project I ordered them for, and it was probably those.
It was almost certainly that. It's the red demo. If people want to go and look, we could maybe try and link that in here too.
Okay.
But the Golioth red demo was our thread-based demo, and that's what we took to an early embedded world. Anywho, so I think when we add other stuff here, it's got to kind of go around the edge here. But basically the extents of this design are the bottom of this connector here, and then just the switch. We don't have to have the switch either, but I think that's generally a good idea. Circles are terrible to work with, and then I would imagine we'd have to have like a UFL to like a patch antenna that would be like one of those sticky patch antennas that goes to the inside of the case, and then that would be our test there. I don't know if this would work. I think it would.
Nice. Should we jump over to the schematic?
Yes, schematic, sorry. Okay, so select this. Okay, so this is actually the same schematic symbol that we use for both on the modules when I'm designing it and the thing that it would land on. So I'm going to call that the host board. In this case, the circle DRAM is the host board, and that would use the same thing. And you see that we have pin numbers, which are matched to the footprint that I created for the castellated edge board. But what we really have to do is, so like we'd have to, on the host board, the Sloshy McWashy in this case, we have to provide it 3 volts, right? So that's be the 3v3. And so that would basically be the battery going in there, and then kind of conditioning we'd want to do on that. We would have to hook up any other signals here. So you see I have hooked up here? This is all hooked up this is actually still copied from the micro DRAM. So I was basically hooking up to the pin connections for the microbus click header. And so a lot of this stuff would actually go away, right? So we'd want to rename these to be just like kind of SCL SDA. So that would be going to the accelerometer. Mm-hmm. There is no room for a SIM card holder. So we would either, like even an MFF2, which is like the eSIM, that wouldn't fit either. So we would just have to use something like an Anomondo programmed directly into the M9151, which is a iSIM effectively. And then we have kind of all these other signals that are available here, but we aren't necessarily using. And then these are not hooked up yet, but these definitely need to be hooked up. So this is the USB to UART. This is going to the CP2102, the USB to serial chip. These need to be hooked up here. And then what does not need to be hooked up? So we definitely don't need this stuff. A lot of this stuff is kind of like suggested. So I would probably keep the interrupt pin here. I don't think we need serial output. We actually don't need the external SPI, as far as I know. We're not using any SPI
so.
sensors, right? PWM we might want for like an LED, right? We might have like a breathing LED sort of thing. So we could leave that for now, and then this could go as well. And then I know this is a little bit confusing here, but this is USB P and N here. This is kind of a bonus one. So like on the DRAM2 module where there's an nRF52840, it actually has a USB transceiver on it. Wouldn't be the best like way to do it, but you could have like USB host there instead of having USB to serial on the CP2102. And then we would definitely want these programming lines. Did any of this stuff I just said make sense?
I think so. For the DRAM, what is the could you walk through the process for programming I guess it depends on the module, right? But for programming the let's say C3 and the 9151.
C3 and 9151. Okay, so on the DRAM 1.
Yeah, that'd be great.
So on the 9151, well, we're actually not going to use the DRAM 1, right? So just
pick your favorite or whichever.
Well, I mean, actually, to talk about the things that are, I should probably put some labels here. But this one, DRAM 1 is 9151 main controller, ESP32 secondary Wi-Fi modem, basically ESP in AT mode. DRAM 2 is nRF52840 Bluetooth chip with a BG77 cellular offload. We're not using either of those. DRAM 3 is an ESP32C3 main controller, so it also has Bluetooth and Wi-Fi on it, and then a BG77 cellular offload. So actually in that case, we don't currently have a way to put a iSIM on there. That's something I assume is possible, but I've not seen that done yet, so that would be potentially a limiting factor there. So we'd either have to fit an MFF2 like eSIM on the board, or figure out how to program the iSIM into the BG77. DRAM 4, this last one here, this one is the ESP32S3, and then BG77 cellular offload. It's the same problem there. So really we'd be planning to design with DRAM 3, but the signals wouldn't necessarily change. I think on programming an ESP32C3, which is what DRAM 3 would be, we would do so over serial, right? That's most of the time we're doing that sort of thing. And so we have a boot pin, we have a reset pin, and usually that's what you do on just about any ESP32C3. You hold down the boot pin, you reset it, and then it wakes up in bootloader mode. So that is the thought there, but saying that out loud now makes me think we should be on this Sloshy McWashy board. We don't need the the SWD IO and clock are not as critical as having the boot and reset, at least on a card edge, because you want to have that when you go to production too. You want to be able to like access this on like a bed of nails sort of thing.
Right. That's kind of where I was going. I was curious if we needed the program header here. Sorry, on DRAM 3 we have the. Go ahead.
Well, one thing to note is like, assuming you don't know in either case, like in best, like we could probably start setting up like a list of like best practices, but like you want them all if you can, right?
Right.
Because you don't want to. It's probably way overdoing it, right? This is like the disease of like modularity. It's like you have to carry all these costs with you, right? So like if you want to have the ability to program it when you stick up DRAM 2 on there, you need to have the SWD pins available, right? You could maybe make it smaller by just having contact pins instead of maybe the whole tag connect header, but like that's something that you have to carry with you then, and that you might optimize out.
Gotcha. So on the DRAM 3, that's the BG77, is that right?
That's right. Yep.
And so how are we accessing it?
So that one comes programmed with AT command set, and then ESP32 talks to it directly over serial.
So if you needed to update the firmware on the BG70? Do they even have firmware blobs that you can update?
Yeah.
Yeah.
Yep.
I think that has to be done over USB though. So in that case, we would hook those. So like these two pins, these USB DN and DP, that would probably go to the BG77. So you could just touch on those and reprogram it. It would be like, you probably wouldn't have the best connection there, but you could wire it up, make it work, sort of thing.
I don't know that it has to be done over USB. I know that I talked to the rack wireless folks about the BG95, and that one, like, you can do it over USB, but you have to reflow resistors on the dev board to change what the USB is connected to, which is not my cup of tea for 0201 resistors or whatever they are.
Could be
but
fun.
They have a firmware example where you can send the firmware to the controller. On that board it's an NRF52, and then it'll upgrade the modem that way.
Okay.
Gotcha. Cool. And
yeah, I mean, this is actually a good stress test as well for like these modules, right? I mean, like, I have them all hooked up and ready to go, but like, you really won't know that the modules are truly like abstracted out and like, same functionality unless you have this good to go, right? So
yeah. And was there I mean, I could just pull this up on my own machine too, but there's a USB to serial component as well on the DRAM.
Not on the DRAM, no.
Oh,
so that's
basically
the requirement to talk to the board is that you have a USB to serial on the host board, and then you because then the carrying cost, like, where does that carrying cost live? It lives on the because like some applications actually wouldn't need USB to serial at all, right? You could just have it self-contained. It could just have OTA. You could talk to it over the network. Like, thinking about like how you'd carry that down the line, sort of thing. You could just have headers even, right? So say you were making like a higher volume, but maybe not super high volume product, and you didn't want to have a USB connection on there. Well, you could just have RxTX available to actually go and program and talk to the DRAM module, but then you don't carry the cost of having a USB connector and a USB to serial chip on your product, right? You just have it when it's opened and serviceable, right? That sort of thing.
Yeah, and also the C3 has built-in USB to serial as well, so you could also just do it over USB if you wanted. Well, I guess that depends on how the DRAM is wired, right?
That's right. Yep.
Yeah.
I would think you could do USB CDC on the 91 as well, or the which is the chip's not the 91. It's 9151. That's what it is.
It does not have a USB transceiver, I'm pretty sure.
I'm just like, you can do with an NRF52, you can do software USB. I'm guessing you could do the same on the 91. I haven't tried it.
No, I'm saying that the NRF52 and 53 plus series have USB transceivers on them. So they have a D plus D minus. 91 series does not have that.
Okay.
Which is also why, so if you look at like something like the
Thingy 91, try to program that.
Right. That's got a 52 running the show with the USB.
Okay. Yeah.
I might be talking out of my butt right now, but this one, I'm looking at the 9151 dev board, but at least on the 9160 DK board, right? It has to have that NRF52840 that lives on the NRF 9160 DK board is actually running the USB show. And same thing on the Thingy. So the Thingy 91, when you plug a USB cable into this, there's actually a default firmware image on the NRF52840 in here that's talking USB out to your computer. And then that's giving it a connection to the 9160. There is no connection. So.
As all the people who work at Nordic are tearing their hair out right now, just talking about this stuff. I don't think the 52 on the 9160 DK is running the USB, because I think that it's the debugging chip.
It's the debugger, right? But there's a separate USB. You're right about that, yeah. But there's a separate USB plug, I think. I'll talk on my butt again. I don't know. But anyways.
Yeah, Helmet's got us in the comments here.
Okay. Oh, I'm full screen. I can't see his comments. Shoot.
Yeah, I was just, I had this sitting on my, well, you can't actually see it. I had this set up, which I use all the time, sitting on my desk here, where I'm programming the Thingy with the 91 DK with the programming chip here. So that was top of mind for me. Although it is really nice that the 91 DK board I use for that function all the time.
Program the other stuff. Yeah, totally.
Super nice offboard debug.
Yeah.
Yes.
Yeah, for sure.
Yes. Right. And so the Elixir board, right? So this one was derived from the 9160 Feather from Circuit Dojo, right? And so like this is not like Chris figuring anything out. This is Jared Wolf figuring things out, right? And so this right here is the USB to serial chip. This again is just straight from Jared's design. And so this is what's ultimately programming here. So
Nice.
Okay.
Back to the
so that carrying
board.
cost goes on the host board, in this case Sloshy McWashy. Let's do this. So I'm gonna using my screen still. I know this design is getting kind of wildly overdone, but I'm gonna do this, copy, paste. A mistake I made earlier. Need to edit this. Give this a new.
You need a bigger piece of paper to print this out, Chris.
I know. Sloshy McWashy. We're just doing this for now. This probably will become its own. It would become its own design later. But Sloshy McWashy. And what this is going to say is like, all right, I'm going to go. You're not like making the same version of the same schematic here, so now I'm going to go and give you new reference designators, and it's going to dump everything onto an. There we go. So create a new file with contents of circle train. So there we go. I add these as separate labels. Sloshy McWashy. Oops, I did that. Sorry. Not mean to do that. Yeah. Chris is not allowed to click StreamYard anymore. And then if I hit F8, let me do it here too. Sloshy McWashy. And I do this just because like all these schematics should start looking the same. So yeah, want to make sure that I do this sort of thing. And then hit F8. And then we should import a whole bunch of new components.
Ooh,
nice.
Wow, that's cool.
Yeah. Unfortunately, it doesn't like copy the same like layout here. So I think the other thing I could do is I could go and like literally copy and paste this sort of thing. But like now we're kind of back to the starting point, right? And we could copy this, modify it, whatever we want to, but we can start ripping stuff off of here too. Right? That's another nice thing. So like in this case, we probably want to get rid of, maybe we want to get rid of the JTAG, but we keep some of the test points here, that sort of thing. We said we were going to be using the LIS3DH. Is that right?
I'll double check the notes.
So now that we're in our own thing here, I'm just going to rename this SCL. One thing that got me pretty badly when I started making all these like separate designs, you know, this is like a lot of designs in one PCB, is that I had them all as hierarchical labels. So like this kind of label here. So if I did this instead, I had them all labeled like this. And the problem with that is when you have multiple sheets and they all have this hierarchical label here, the net is connected across every sheet you have. So you don't want to do that. These localized labels are what you want, because then it won't try and connect them across all the boards that you have. So that's,
how did you find that out?
It had little rat's nests going to every single board. I was like, oh,
this is a very complicated design.
Yeah, right. Even in this case, they're all the same ground. So it's still going to create a connection there, but like, you know, we could also rename the grounds if we wanted. This is not the best way to do things. This is really like a kludge in this case.
Figure this one out, auto router.
Yeah, right. No, come on, auto router. Never trust the auto router.
Now, haven't you heard that AI
is going to fix it, right? Yeah. If AI could fix my mistakes, it makes Mike's life a lot easier. To quote Ron White, you can't fix stupid.
Yeah. They haven't invented an AI smart enough to fix the kind of mistakes I create.
That's right. So let's call this accelerometer meter interrupt, right? Just to be like very explicit here. We really don't have a lot of other things going on here, right? I mean, like, so we're gonna have a single sensor. Is that right?
Yep.
Okay. We definitely want to hook up reset.
Chris can't take it. Give me more.
I mean, like, why do you even bother with a single thing? You know, like,
why even make it?
well, I think one thing that is kind of relevant is like you wouldn't do it right away, right? You wouldn't, and we're not either, right? We're also we're doing this on dev boards first, and then it would migrate to something like this. So you wouldn't necessarily go straight to this. Let's do this. Let's do a label 3v3. Now this is something that I am not sure about either, because we have said 3v3, but that battery is sure only 3 volts. So, and I'm not going to put a booster circuit on there. So I think that's another thing we'd have to check is like kind of like there's no data sheet for the DRAM module, but also like how low could it operate? Could it operate down to 2.5 volts? So, I don't know. I think so, but it's not. No guarantees have been made. Did we say we're gonna have like an LED? Like, what kind of like user indication we've been talking about?
We haven't talked about it at all.
We're gonna force Mike to write a driver for WS2812.
No.
I mean, I feel like some indicator would be good.
Okay.
But let's go as simple as possible.
Okay. I mean, so we could do basically, we could just say like there's going to be a red-green sort of thing. So then you just do something like this, right? You'd say red here.
For me, but yeah.
Oh, right. Well, I mean, yeah, but then you can do patterns and stuff like that.
Yeah.
What colors can you see?
Red and green. Oh, can I see?
Yeah.
Well, I'm red-green colorblind. It really bleeds into lots of different colors, but usually if you have like a very cold, well, I guess green is a cold color, so maybe that's not true. But usually if it's like blue and like yellow, you know, that's kind of where we're getting blue and blue adjacent colors look very different from like hot colors to me.
If you're just
so like you would see like two versions of like hot and cold, like you see sort of thing.
Yeah, I don't actually know how it works, honestly. I think that it's
cones and rods, I think.
Yeah, something of that, but
I usually shouldn't do blue just for the voltage drop, Chris. If you're talking about running these on a low rail.
Sorry, Mike, can you repeat yourself?
The voltage drop on blue LEDs, aren't you going to have a problem if you're talking about running this?
Oh, that's a good point. Down? Yeah.
Do red and then red or red. I don't know what a full forward voltage of an amber is, but amber and
you know what? I figured it out. Here we go.
Red LED and green is fine. Yeah.
Ooh.
LED 2. I just figured it out. Smart. Look at that. Yeah.
You should put a resistor in there for those too.
Well, there's no actual resistors. There's no actual LEDs here yet, right? This is just indicating that we would have these signals. We'd be using the signals coming out of the core module here.
I see. So you're just naming the nets. Got it.
That's right. Yep. But what I'm trying to draw out of you guys is what else do we need? Like we want a user button, maybe. So we do that here. And what you see here is that I have these kind of names that we created. These are like very arbitrary names. It's DRAM GPIO number. And then some of them have additional, like this is a simple GPIO only. Like this one can be used for a bunch of different things, including PWM. But like this is, you can use the simple one just for like on off sort of thing. Like nothing fancy there, because on some DRAM modules, it might be on an expander, right? So that's kind of the idea there. Okay. User button, delete, and then user button in. Okay, no other functions. It's just an accelerometer. I didn't come up with anything else. Did we talk about like a magnetic sensor?
Let it happen,
or like
Chris. Let it happen. Let it be simple.
Oh my God.
Well,
do
we need a power switch if we're running from battery?
Power switch. That is actually on here currently. That is up here.
Okay, great.
Yep. This is just ripped off of the.
Button switches. Okay, great.
Yeah, this is basically.
So we do have switches.
We do have buttons and switches.
Great. Yeah.
Yep.
I think of buttons as switches myself.
Yeah.
Toggle switch and momentary push switch.
Yeah.
Push button.
Okay.
Yeah.
So nothing else. That's it. It's just an accelerometer board.
Yeah, let's do it.
Are you sure, Dan?
I'm so sure. I've never been more sure of anything.
You know what? Since it's a round form factor, let's put one of those color OLED screens from sports watches on there. That way we can sell upmarket, right? Yeah, I mean, the thought is like if you go to the laundromat and you leave this on the machine, you don't want it to be something interesting enough to steal.
Yeah. You want it to just be a puck.
Yeah. Out of machined aluminum. With an external antenna.
Nothing else? Like what's the other one? Like a Hall effect? So you could do like a spinny type thing on there? Nothing?
I mean, if you want to.
I don't know. It just seems like such a waste. Like
if you want to juicero it up, then
do you want a juicero? This is how you get a juicero. All right.
Helm says that TI has a low power linear Hall effect sensor.
Huh. Okay. Not bad.
But then you're talking about a case that has moving parts and has a magnet in it, right? Well, I mean, it's going to have a magnet in the case.
Well, this is going to have a magnet in it. Yeah. I mean, you could do it. I mean, so one thing
this is why we haven't really specs before we started on the hardware.
Story of my life, man. Story of my life. Okay, so this thing, just to maybe Dan, you can run us back through some of the specs of the product. Let's go back. I'm gonna go to your notes, okay?
Yeah, let me jump back to one of our previous ones here. Let's see, like the 12th, maybe. This might be lacking. Specs on the product. We asked the question, how long does the battery need to last? I don't think we had an answer. But multiple uses, I would say. And form factor, magnetic, Thingy 91 or smaller. I think we're in that range.
Yeah.
Thingy
91 is small. Yeah, this is I know this is the worst circle that has ever been cut out. I tried cutting out this is a little bit. This is effectively this. Yeah, it's really not a circle. Turns out when you don't have a compass at home.
I was talking about the size comparison, not judging your circle scale.
Oh, well, you should have also judged. That looks kind of like, that's kind of curved. But anyways, that's about the rough size there. So, and again, like this is so important to this is where all this started. Sorry if is this the right one? Yeah, this is the size of the DRAM module, right? And this is where, so like this is the DRAM module. This is the, you can't see pink on pink, but this is the micro DRAM, right? So like slightly larger, right? So that's kind of like the smallest form factor I could make using the DRAM, where the DRAM's on the back, and then you have stuff on the top of it. That's like the smallest one, and then this is like basically like the smallest circular form factor. Again, not really a circle, but. And just showing off my sweet tattoos as well. Come on, look at that. It's nice. Summer.
Are you a Rust fan?
I am not. That is just coincidence. I'm not a Rust fan. I'm just not, one of those.
Right, exactly.
Like a advocate.
Rust? Okay, so what were you looking for, something in particular here?
Well, yeah, and so like what I was wondering is like so when I get to this point in a design, what I'm thinking is footprints are free, right? We don't have a ton of space, at least on the circular dram, whatever I call it, circle dram. Like there's not like a ton of space there, but like if you can squeeze it in, if you could squeeze anything else in and you think you might ever need it at this point, especially in early stages, you should do it, right? I mean, we're talking about prototyping off. You know, you don't start with just this size form factor. You start with something that's more reasonable, like a dev board or an Elixir board, or, you know, maybe the micro dram at some point. But like, you don't start with the final form factor unless you're really a masochist, which I have been known to be, right? Because that means then you're probing on these things that like you don't know where all your dragons live in your design yet. And so, yeah, that's not the right way to, you shouldn't drive towards that final form factor right away, but it is good to know it a little bit at the beginning. Like we want it to be puck-like. Okay, great. We want it to be battery powered, important. But we don't have any other, like, we're just detecting vibration. We're not detecting whether the magnet's working. We're not detecting any kind of opening. Really just thinking about like other actuations and other things that we're testing for, right? What else are we testing for?
We're not testing for anything else right now. We can test for more though, if you'd like to.
Well, yeah, okay, yes. I mean, yes. Okay, then Rev A, only an accelerometer. Much as it pains me.
Look, take us another way. I need some opinions if you don't want just the accelerometer.
Okay, so other things I could think about. So yeah. The Hall effect sensor, right? So say we were going to do a puck, so you have vibration, but then say you had like you know, you could do it with a reed switch, you could do it with a Hall effect, but you could have a secondary magnet, a magnet on a magnet next to it, and then you have that next to the door, and then when the door opens, you know that the magnet is now gone. Right, that's another thing you could do to detect open close. You could do things like that. Yeah.
So like that would be the case in which like tying that to actual like user interactivity here. That would be the case in which someone like stopped your laundry and opened the door.
Right. Yes. Again, it doesn't have to be. I'm just saying, like, making just a, you know. I also have a connected accelerometer right now, right? Like we're basically making the same thing that it's been made lots of times. It's just different form factors, so it's not bad. It's just, you know, it's been made. And other ways we might be detecting things around laundry, you know, that sort of thing.
We can do the door open thing if you'd like.
Yeah.
We have 1 hour. Remind you, we have 1 hour a week to work on this. So
yeah, right.
Being a little simpler might not be the worst thing here.
Okay. Yes, you're right. Okay. I don't think I have a model for the LAS3DH.
Also, I switched back over to you.
Oh, I do. Never mind. Look at that. Okay. Oh yeah. Done.
Nice.
And it looks like we actually do have 2 available interrupts, so we could hook those both up. That's kind of free, so we can do that. Often those are like kind of like a fall detect, that sort of thing. You might have a secondary second interrupt for, you know, you have different program modes in the accelerometer. Accelerometers are so impressive. Like, why would you ever need anything else, really?
He's bitter.
Just trolling a little bit. Okay.
Do you have both of those hooked up on the Aludel Elixir?
Both of which hooked up?
Both of those interrupts?
No.
Do you have either of them hooked up?
Yes. Interrupt 1, and I think there's a pin. I think there's a, let's see. I think I broke out the other one to a pin. Looking right now. Or I should have. That's the other thing I should have done. I think there's actually an extra resistor. Schematic.
Wake up and free fall.
Yeah. That's
so what is that like? If you're a laptop, you detect a free fall, so you park the spinning disc, or like what's?
That's exactly right. That's why these are cheap. Yes.
Don't they sometimes also use that for like if you're in like low power mode, you like it'll like wake you up on free fall and then start measuring after that.
It generate an inertial wake up and free fall interrupt. So it sounds like those are different. Both free fall and wake up can be available simultaneously on 2 different pins.
Oh, interesting.
What is wake up?
Yeah, wake up's just the normal one. I thought that was just the normal use case.
Oh, you can define what the acceleration event is. That's kind of cool.
Yeah. So you notice that this one also has other pins for, you can actually run it in SPI mode. I don't think there's any benefit to doing that, but this could also be run in SPI mode. I think the driver in Zephyr is I2C, which makes sense.
Yeah. I'm going to pull that up.
Did we use this accelerometer for something in the past, Chris?
This is the a different version. We use the 2 DH. Okay. And I think ADC 1, 2, 3. Actually, I don't know. Are those that? I thought that was the way to have multiple pins, but maybe this is actually access to the ADC's signals, like the analog signals coming out.
It's page 33 of the data sheet. Navigating to page 33.
Want to share your screen, Mike, or no?
Out. Auxiliary 10-bit ADC channel 1 conversion for auxiliary ADC setting.
Oh, you can actually do I2C or SPI.
That's right. Yep. But like I said, the driver I think is what's limiting on that one. I think the
no, I'm saying I'm looking at the driver.
The driver's okay. Okay.
Yeah.
These are inputs.
Huh.
Contains an auxiliary ADC with 3 separate dedicated inputs, pins ADC1, ADC2, ADC3.
Guys, you're supposed to stop me on this. Look at this. You must let me do this. I always do that.
We both have other screens.
So do we need to measure anything? We don't have anything on the
board.
We're
not doing any other functions with this. No, that's true. Well, we also have analog. So we also have an analog pins on the part as well, right? So that's another thing we have here. So we could do that on either of those. It might be better on low power sleep sort of thing. Oh, here's a feature I just found in KiCad 8 that I was telling Mike about. So these are hierarchical labels right now. So that means that anything on this whole design, these are all hooked up from, this is because I copied it from the Elixir, where I use all hierarchical. Select them, right click, change to label. Look at that. That's cool. That's beautiful. Yeah.
Now, which pins do those RX and TX connect to?
So this goes to the same labeled one, right? So this goes to USB UART-TX, and you see that the swap happens at my oh shit resistors, pardon my French. These are the resistors that you have here, so that when you do eventually switch RX and TX, you can put in your BODs right here. Always put in, let's say, oh crap resistors. I always put those in. X. Can I mess this up too, though? It's a special talent that I have.
I see how you named them. Okay, that makes sense.
Yeah.
So
this is really, I should really change this to the real the real thing that I like to do, I usually do TX from blank, RX to blank. That's like the best way to do it, I think. So in this case, it would be like, let me just go back over to the USB to serial. I find that's the clearest thing. It would be, this signal should really be TX from CP2102 RX to micro, right? That would be like that's the best name that I have found. I've still messed that up too. Don't get me wrong. I mean, I can mess anything up, right?
I feel like I was telling myself, because I've been going through as Chris knows, I've been going through the Elixir design or the schematic and just like annotating it for my own benefit. So I told myself that on the streams I would ask more questions about stuff here. And I was curious, the resistor values on the USB to serial power. Can you talk about why those values were chosen?
So this is 5 volts in, and this part is internally, it's got a regulator. So it says 5 volts, it goes into VREG in. And that means that the IO of this part is actually 3.3 volts. And so if you put 5 volts into the V bus pin, which is really just detecting whether V bus is there or not, you will fry that sucker. Ask me how I know. Yeah, so that is that's a voltage divider that basically takes 5 volts down to 3.3.
Nice.
And you can see it's roughly 2/3ing kind of thing.
Yeah. Cool.
All right. This one needs to be converted as well. Label. Change to. And then that one, that is this signal here. So this is another one that comes from the Jared Wolf's Circuit Dojo's NRF9160 Feather. But basically, this is this pulls down on the signal to, this is basically the mode pin. This is like the mode pin to put it into bootloader mode. Change to, there we go. All right, well, we didn't need to add much here. I'm sure I should check these other pins as well. Like, Mike, did you have the schematic up or no? Or the data sheet up? Or can you share it in the chat?
Sure. Like the link to it?
Yeah, we can put the link in the chat so everybody can see it. Or we can share a screen if you want to.
Yeah, I can share my screen. Hang on. Share screen. Huh. There we go. All right, what am I looking for?
I would just look for, usually at this point, I would be looking for like an application circuit because I want to just make sure that so I'd look for the I2C application circuit in this case. It's a great way to know whether you have the right decoupling capacitors, which Dan and I have talked about on other designs in the past. So Dan's like, why do you have these specific values of decoupling capacitor? Which is a great question. And the answer is, I have no idea most of the time. Often it's because of, the frequency you'd want to have. So like in this case, that's a 0.1 microfarad or 100 nanofarad and a 10 microfarad. I have 0.1 and 4.7. So I could change that over, right? Like, okay, that works great.
Yeah, I see those as like the common recommended all the time. 10 and 100.
Yep.
The other one, the one that I really went down a rabbit hole on was on the USB connector. Why the 5.1 pull down resistors and why that value was chosen. But yeah, it turns out they just tell you to do that in the spec. So, and
Just do
you
it,
move
man.
along with your life. So,
Don't ask questions. I mean, there are very real reasons. It's just most of the time, especially for people that I have tutored before getting started in electronics and stuff like that. It's just like it's so confusing because there's all these things that are in schematics, and most of the time, grumpy old people like myself will say, "Just don't worry about it," And it's like that is not a satisfying answer.
it is not. You're right.
I'm sorry, Dan.
I'm
That's the best you're gonna get.
Oh, this is rotated. I was like, what's going on here?
So what are you learning from this, Chris?
I'm not watching your screen. I don't know. That I need to have pull-up resistors. That's a general. That's a good lesson. Apparently, I don't have any 10K resistors on anywhere on this board. Is that possible? No, there's some.
Do you have 1K? You can put 10 of those on.
In parallel, Mike? That is not good. Sheet. Yeah, so I mean, honestly, looks pretty straightforward, which is great. I'm going to actually put these, if someone could switch back to my screen, I'm going to put these 10Ks on the board, which is fine. But then I'm going to actually make them optional. And up here. So this is the stuff you'd have here. Mark do not populate. It's very clearly, this is a new KiCad 8 feature as well. That's nice. Way to toggle this. I forget how to do it. Where is it? Select the whole part. Right click, attributes, toggle, exclude from board. Oh, toggle do not populate. Control Alt X. Let's try that. Control Alt. Not the easiest one. Mike could map that to a keyboard key on this fancy keyboard, I'm sure.
Yeah, the thumb X, right thumb X would do that for sure.
That's on layer 12 of the key.
Yeah, that's right. Yeah. All you have to do is write a 14-page script in Vim.
Yeah. We're in Lua now,
right
Chris.
now, guys.
Thank you. What did you say?
I'm down to 3 layers. I guess 4.
You're so
14. Why is this listed as a DMP? So some of this stuff is actually legacy from the Elixir. I had on older versions of KiCad, I think 6, maybe, well, whatever. I used to have these population fields, and that's different now, right? So it actually uses, so now it's built into KiCad instead of needing a separate field that I put in there. That's just a cleanup item I have to do. And if you use the built-in one, then you actually get this nice big indicator that says, do not populate this. Okay, so we've got buttons.
I think that I was not paying attention for a minute. Why did you mark those resistors as do not place or do not populate?
Do not populate. I think. Well, I thought we had other ones on this board, but I guess this board's different. There's probably pull-up. So there's also pull-ups. I will always put footprints there for this sort of thing, because like if you need additional pull-ups at the chipset itself, and I think it's better to have them there than not have them there. But then often you can enable pull-ups directly in the pins. So like if you have a very tight design, you could probably get away with just having a pull-up directly in the GPIO of the part you're using. So in the ESP32C3, we can set whatever pins are assigned to the SDA-SCL as pull-ups as well, I think.
Gotcha.
So often you can do that sort of thing. And then the reason to do something like that, if you have it like that, is you don't have, even though it's only 10K, those 10Ks are just going to be siphoning current when you're operating, right? So it's better to instead use something like pin control and Zephyr, have kind of the active mode where the pin-up pull-ups are enabled, and then it's in active mode. And then when it goes to sleep, it disables the pull-ups and it says, all right, now it's just tri-state, and it's not. Then it's just the normal leakage of a tri-stated pin. So you could really start to save power like that.
Cool.
But again, I will always put these here because then when you're in testing, say you were like, say you've got everything hooked up, everything's going how you expect it to be, an easy test is you go and put some 10K or even 1K pull-up resistors on there, and just does that fix it? I know that's very brute force, but if it does, then it gives you a hint to be like, okay, it's probably something with signal integrity and like how much current drawing here, and then that gives you another place to do it and not have to like cut a trace and like wire a resistance sort of thing. So
cool. That makes
it's a carrying cost, but I think a pretty low cost.
Nice.
Okay. So yeah, I think we're done.
Nice. I also had to hop off here in a minute. I didn't realize we were already 15 minutes over. But y'all are welcome to keep going, or we can wrap up for the.
No, I think we can wrap this up. Yeah.
Cool. Awesome. Well, thanks for.
If we have any to-do items, I think to-do items for me would be continue to check into this sort of thing. I think for the ESP32C3, this is going to be fine. The pin here is fine, or sorry, the battery here is fine. But something like if we have a BG77 on there, I don't know. So like maximum draw of a Cat M1 with BG77, if we were going to have that sort of thing, which is, who knows? That's pretty far down the line. We're not even talking about populating. We would use a DRAM 3A where there's no cell modem populated, which is fine. But you still have to like kind of plan ahead for that sort of thing.
Cool. Well, thanks for walking through all of that. That was super informative. And for entertaining my questions.
Making the IoT product stream just another hardware stream, right?
Right. Hey, that's fine with me.
I mean, now that the accelerometer's here, I think I'm done. I think we just figure out the form factor, hand it off to John for the 3D printing, and we're good to go.
I'm ready. Cool. Okay. Actually, we should do one stream on getting the notifications onto folks' phone, because there are a few ways you can do that with pipelines now. One of which is Slack, which I made that video of this week, but there's also some SMS options as well, or MMS or WhatsApp.
That's direct out of pipelines instead of having to use something like an N8N to do that. You can just do a webhook to like a pipeline or to a Twilio or something.
Yeah, it's Twilio. Yeah.
Okay. Cool.
Yeah. Cool.
I'd love to see that.
Yeah. All right. Well, Jonathan said he's ready also. So next stream, he'll print it.
Fire up the 3D printer, John.
Yeah. Cool. Well, thank you all for joining, and thanks to everyone in the audience, especially Helmet, for your helpful input. So I'll hope you all have a great weekend, and we'll do it again next week.
All right.
Cool.
Bye.